Problem 208, Classical Mechanics. The question is, the parabolic coordinate psi comma eta are related to the Cartesian coordinate xy by x is equal to psi eta and y is equal to 1 by 2 psi square minus eta square. The Lagrangian of a two-dimensional simple harmonic oscillator of mass m and angular frequency omega is. In the present problem, it is given that x is equal to psi eta, where psi and eta are parabolic coordinates, and y is equal to 1 by 2 into psi square minus eta square. We have to find out the Lagrangian of the two-dimensional simple harmonic oscillator in terms of this parabolic coordinate psi and eta. For this, first let us write the Lagrangian of a 2D harmonic oscillator in terms of the Cartesian coordinate xy. For a 2D harmonic oscillator, we know that L is equal to half m x dot square plus y dot square minus half m omega square x square plus y square. This is the expression for the Lagrangian for a 2D harmonic oscillator. Here the kinetic energy is half m x dot square plus y dot square and the potential energy is half m omega square x square plus y square. It is given that x is equal to psi eta and y is equal to 1 by 2 psi square minus eta square. First let us find out x dot. X dot is equal to psi dot eta plus eta dot psi. Then what is y dot? Here there is a 1 by 2 which is common, and if you take the derivative, the first term becomes 2 times psi, there is a 1 by 2 factor outside, into psi dot. So the answer is psi dot. Similarly, for the second term we have 1 by 2 into 2 times eta into eta dot. That is eta dot. That is y dot is equal to psi dot minus eta dot. Now let us substitute the value of x dot and y dot in the expression for the Lagrangian. We have L is equal to half m. The first term is x dot square. We have x dot is psi dot eta plus psi eta dot. Therefore, the first term is psi dot eta plus psi eta dot square plus the second term is y dot square. What is y dot? Y dot is psi dot minus eta dot. Therefore, the second term is psi dot minus eta dot square. This is the first term, that is the kinetic energy term. Then the second term is 1 by 2 m omega square into x square plus y square. Here x square is psi eta whole square, that is I square eta square, plus y square. Here we have 1 by 2. Therefore, y square is 1 by 4 into psi square minus eta square whole square. Psi square minus eta square whole square. This is the second term. Now let us expand the first term, the kinetic energy term, that is half m. If we expand this term, we will get psi square eta square plus eta square psi dot square plus we have 2 times eta dot psi dot eta psi. That is our first term is psi dot square eta square plus psi square eta dot square plus 2 psi dot eta psi eta dot. Now let us expand this term, second term, that is psi square psi dot square plus eta dot square minus 2 times psi dot eta dot. Now we can clearly see that this term and this term cancel. So we have only 4 terms inside the bracket. That is, our first term contains psi dot square eta square plus psi square eta dot square plus psi dot square plus eta dot square. Now let us expand the second term. Here let us take 1 by 4 outside the bracket. So if you take 1 by 4 outside the bracket, the first term is 1 by 8 m omega square. Then this term, the first term becomes 4 times psi square eta square. If you take 4 outside, then we have 1 by 8 m omega square outside. So this term becomes 4 times psi square eta square plus, now let us expand this term, that is psi raised to 4 plus eta raised to 4 minus 2 times psi square eta square. Now if you observe, we have the first term 4 times psi square eta square. Now here you have 2 times psi square eta square. So you will be left with 2 times psi square eta square. Also you have psi raised to 4 and eta raised to 4. So the potential energy term is 1 by 8 m omega square within bracket psi raised to 4 plus eta raised to 4 plus 2 times psi square eta square. Now let us further simplify these terms. L is equal to 1 by 2 m into psi square plus eta square. You take it as common. Then eta dot square plus psi dot square minus 1 by 8 m omega square into, we can reduce this term as psi square plus eta square whole square. Here if you look the Lagrangian, we have psi square plus eta square is common in both terms, so we can take it outside. That is, L is equal to 1 by 2 m into psi square plus eta square, then within bracket eta dot square plus psi dot square minus, here we have taken 1 by 2 also outside the bracket. So here you have 1 by 4 omega square, because we have taken m also outside the bracket. Then you have psi square plus eta square